Good morning, class. Well, today we're going to spend a little bit of time taking some notes for just a moment over conditional and biconditional statements. This is going to be the foundation of everything that we do when it comes to proofs and how we go ahead and prove things in this class. So let's get into this. In this class, we're going to say some statements, or we're going to have some ideas that are in a statement form. So our first thing is this. A statement, let me make sure I can have this as clear as possible. A statement is just simply a sentence that is either true or false. Okay? For example, a sentence that might be true is, well, no horses are turquoise. Right? At least naturally born that I'm aware of, there's not really a turquoise horse out there, right? This sentence would be considered true, right? And that no horses are turquoise. I have a statement and I want to show whether it's true or it's false, okay? And so what we do is we associate a truth value with that statement. It's either true or it's false, right? So for this case, our truth value for the statement, all horses are turquoise, no horses are turquoise, is true. Right? Where it's either true or it's false. But then, right, we get into this issue where we want to be able to say all we can about some statements, and it's sometimes helpful for us to look at the opposite of what that statement is saying, right? We want to look at something called the negation, or the opposite value of a statement. So, for example, the negation of no horses are turquoise is, instead of none of them, all of them, right? All horses are turquoise. And in this instance, right, this would be false, right? We've done the opposite value. Instead of true, and now it's false. And this lets us do a lot with conditional statements, okay? In the course that we're taking in geometry, what we're going to end up doing is showing that every statement that we can make can be written in the form if, then, right? If something happens, then there's something else that happens. Okay? And this looks like if P, then Q. Okay? If some statement P, then some other statement Q. This is read as if P, then Q. Or another symbolic form of this is P goes to Q. Okay? Either one makes the same sentence, makes the same thing. Okay? Now, P and Q have very specific names here. The first is this. The hypothesis P, it's a little hard to read that, but hypothesis P is a phrase immediately following the word if. So it's a hypothesis. And then the conclusion, Q, is a phrase immediately followed after the word then. Right? So, in other words, if hypothesis P, then conclusion Q. Okay? Our hypothesis implies our conclusion. Okay? If hypothesis P, then conclusion Q. This is called a conditional statement. Right? Because you need to have the conditions of P to make Q happen. Now, what might the value of this sort of thing be? Well, let's try to mess around with the order a little bit to see maybe if we can notice anything valuable here. So, The first bit is this, the inverse. When we think the word inverse or inverted, we think backwards, right? We think the opposite of something happening. And the word for opposite in our language we're using today is negation, right? It's the opposite value. So we're going to negate the hypothesis and the conclusion. Or in other words, not P goes to not Q. You notice I use this little squiggle right here? That's called not. Not P implies not Q. Or if hypothesis P isn't right, then conclusion Q isn't right, or the not Q, okay? That's called an inverse. So that's the first thing we can do, is we can negate our hypothesis and our conclusion. Another thing we can do is find something called the converse. See, the converse is formed by swapping the hypothesis and my conclusion. I'm going to swap the order, right? So instead of having P goes to Q, instead I'm going to have my conclusion Q go to P, right? All I've done is swapped the order from P to Q. And so you've seen the symbolic form of this is Q goes to P. We swap the order of the hypothesis and the conclusion. Two last things, and then we'll kind of move into practicing this with some examples here. The contrapositive, that's the third thing we haven't done yet. Okay? The contrapositive is formed by swapping and negating the hypothesis and the conclusion. Or in other words, negating the hypothesis and conclusion of the converse. And so we write this as not Q goes to not P. We're going to swap and negate the hypothesis and conclusion. All right. Last sort of thing right here. Bi-conditional statements. Okay? What this means is that the truth values of the conditional and converse are the same. Or in other words, P goes to Q and Q goes to P. Okay? You see this little hat symbol right here? This means and. So P goes to Q and Q goes to P. In other words, P, if and only if Q. You see how I write IFF? That means if and only if. P, if and only if Q. And they are true when the hypothesis and conclusion are swappable or interchangeable. The order doesn't matter. Okay, let's try some examples to see this in action. All right, example number 1. It says, identify the hypothesis and the conclusion of the following conditional statement. If you live in Nashville, then you live in Tennessee. Well, remember, a conditional statement, right, is in the form if P, then Q. So our hypothesis, P, is you live in Nashville. And then our Q is our conclusion, right? You live in Tennessee. You live in Tennessee. Okay? Simple as that. If P, then Q. Example 2 gets a little bit more challenging. We have to now write the inverse, the converse, and the contrapositive of this statement right here. Then determine the truth value. And if it's false, we have to show why. So, if it is Saturday, so let's break this down. If, there's our if, hypothesis is that it is Saturday. Then conclusion, there is no school. All right? So if it is Saturday, then there is no school. The inverse is when we negate P and Q. So if it is not Saturday, then, well, instead of saying that there is no school, we're going to say there is school. Then there is school. So if it is not Saturday, then there is school. Is that true or false? Well, is Saturday the only day when there's no school? No, Sunday. We also don't have school on Sunday. So we're going to say false. Because Sunday is not Saturday, and we don't have school on that day, right? If it is not Saturday, then there is school. That's false. There's Sunday as well. Now the converse, instead of negating my hypothesis and my conclusion, I'm going to swap the order. So if there is no school, then it is Saturday. Is that true or false? Same reason as the first, right? Just because there's no school doesn't mean it's Saturday. It could also be Sunday, right? Or some other holiday. So it could be Sunday, it could be a holiday, right? There's other days where there's no school. And finally, the contrapositive. We're going to swap the order and negate the hypothesis and the conclusion. So, let's break it down. If originally we had there is no school for our conclusion, so we're going to say there is. So if there is school, we're going to negate the hypothesis now. Then it is not Saturday. And is that true or false? If there is school, then it's not Saturday. That makes sense, right? Because it couldn't possibly be Saturday if you're in school. So that has to be true. And if we're just looking at the original statement, if it is Saturday, then there is no school. That is true, right? In American schools, that is very true. If it's Saturday, then there's no school. Now, I want you to notice something. The conditional, this is called the conditional, and the contrapositive have the same truth value. They're both true. And then the inverse and the converse are both false. You see that? Well, here's a really nifty thing. Whenever you find the truth values for the inverse and the converse, they're always going to be the same as each other. So if the inverse is false, the converse will be false. And now the same thing applies for the original conditional statement and my contrapositive. They will also have the same truth value. So if I know that my contrapositive is true, my conditional is true, and vice versa. If my conditional is true, my contrapositive is true. All right, last step, example number 3. We need to determine if it is a bi-conditional statement, right? Is it written as if and only if? So number 1, if you are going to eat, then you are hungry. Is that a bi-conditional statement? Well, no. There's no if and only if. Letter B, Matthew is at the video store if and only if he wants a film from the thriller section. Well, yeah, that's a biconditional statement. It says if and only if. A pizza has oregano if and only if Cole is ordering it. Well, yeah, that's biconditional. It has the if and only if. And lastly, if Vicky has chicken soup for lunch, then she's not feeling well. Not biconditional. I don't have the if and only if. So, thank you guys for watching. Hopefully that this was helpful to help you out with the notes a little bit. Have a great rest of your day.